Yeah, you can get into that. I from there only you will get a option called create over here. Just like you started 3D designing, now from create section you just have to go to circuit. I hope everybody can log into that thing, the circuit profile.
Yeah, done.
Yes. So basically, TinkerCAD, along with 3D designing, what TinkerCAD provides us, it actually provides us how to build the circuit itself. For example, in this platform, we can simulate our circuit, we can draw our circuit, or even we can perform each and every instrument that we can do in the hardware itself. So it is a basic building structure. Before enabling into the hardware thing, we can put everything together and simulate in the online itself so that our hardware does not get damaged, or you can say we don't have any false connection over the hardware itself. So it's a beautiful platform. I'll just give you a guide through of what are the things over here, how we'll be going to use it. Similarly, as you have done in the 3D designing, you can name your circuit over here with XYZ, any name. This search option, or you can say this components, gives you a way varieties of components you see in your electricals or electronic devices, from basics to Arduino to microbit to every circuits you will get over here. Okay, so our task today will be like starting up or make our hands dirty on some real life projects, or you can say the things that we do in the hardware itself. We'll start to build, or we'll start how to simulate in the software itself, so that each of you can get a better understanding of basic electronics components. So first of all, I'll be introducing you the breadboard. You can search over here the breadboard, and there you'll get a different size of breadboard. I will introduce this breadboard to you people. You can drag the thing, and the thing will appear to your window itself, to your working window itself. Now, to understand the breadboard connection, we have to understand its inner design. The breadboards are the middle portion of this breadboard, the that numbers 1, 5, 10 to 60. These are all connected in series. If I hover each of the points, you can see each points are internally connected. That means if I if I get a circuit over here, or if I get a connection over here, I'll get the same connection from it itself only. Okay. So any doubt till now? Like everybody can log into the ThinkerCAD, I hope. You can draw along with me, or you can make the circuit along with me. That will be very helpful to you people. Okay, so this is our breadboard. Along the top two and the bottom two are parallelly connected, or you can say these are connected in this single line, the minus section, as the green line is showing, and the plus is connected in this straight line as the green line is showing. And similarly to the downer portions, we get this green line. That means they are internally connected, and this green lines there means internally connected. So let us start how to blink or how to glow a LED. For that, we'll be needing the first and foremost thing, or the LED itself. In the LED, we know there are two types of terminals in an electrical circuit: the positive and the negative. The negative terminal is known as the cathode, and the positive terminal is known as the anode. So here you can see we have the cathode and have the anode whenever we hover on to the terminal itself. So a very useful thing to protect our LED or protect any of our electronic or electrical devices, we use a register. Register, what is the purpose of a register? It acts as a protective device. It stops the flow of excess amount of current through a circuit. Like everybody will be knowing that. So the principle of the register used to stop the excess flow of current to a particular circuit. So we'll be using a register over here, and the value of my register is, I can change the value form over here. So I'm writing 1 kilo ohm register. I'm taking a 1 kilo ohm register. You can adjust accordingly. So this is my register. Now what I need a power supply. I'm using a 9-volt power supply. Everybody is familiar with this thing, I guess. There's a 9-volt power supply, or you can say the 9-volt battery, what we get over here. Now, the main part of this is to make the connection. How to make the connection? So we have a positive and a negative side of the battery. Now we have the positive and the negative side of the battery. The positive side of the LED has been connected with a register, and the negative side has been taken apart. I will just connect the negative side to the negative side of the battery. You just have to click over it, drag your wire, and you can simply connect it to the negative side of the battery like this. If you want to change the color of the wire, you can go over here and you can change to any of this. Like the negative has always been colored as black, so I'm using the same color coding. And for the positive one, I'll be using the same option. I'll take my circuit, I'll take my mouse over there and connect the positive circuit. So as the positive has always been color coded as red, I'm changing it to red. So this actually completes the circuit, completes my circuit. So what the result I'm expecting? The result I'm expecting is the LED will be glowing with the power from the power source that has been driven by the battery. So how to check it? There is a start simulation option you can see in the top right hand corner. If you click into it, the simulation starts. The simulation starts, or you can say the circuit runs. The current flows to the circuit. Now you can see the LED is glowing, or the electrons are moving from positive terminal to the negative terminal. So we can see the LED is glowing over here. So as I have told you to you people, like register is being used as a protective device. It protects the LED from bursting, or you can say from overloading. So how to check it? Like I have a 9-volt supply and have a register connected to the LED. So what if I remove the register? I need to check that also. So this time I remove the register. I take the positive end of the 9-volt and connect to the other terminal of the LED. So the result I'll be expecting is the LED will burst or the LED will burn out. So if I start the simulation, everybody can see the LED burns out, or it like burst. So this is the purpose. We always use a register with a LED or with any electrical device or electronic device to protect itself. So back to the basics. Putting a register, changing the connection, and getting the final result back. So once this is done, we'll be exploring switches now. So the next principle of an electrical circuit is we need to use switch that can close or open a circuit. So there is a component called slider switch. Slider switch has 3 terminals: terminal 1, common, and terminal 2. The common is been connected to the positive end of a battery. And one of the terminals is being now connected to the one portion of the LED. So what you expect? The result I'll be expecting here is, if I slide the switch, the LED will glow on. If I don't slide the switch, the LED will turn off. So simple. There is a simple circuit which I just switch in it. So if I start the simulation, as the LED is already connected to this portion of the switch, the LED is being turned on. And if I slide the switch, the connection is broken and the LED turns off. So this is the very example of, you can say, the basic example of the switch. Now I can explore the other side of the switch also. Like, there is another terminal. So what if I connect another LED to it? Like, I take a LED. Now let me change the color of the LED. I can simply change the color of the LED form here. The color is
Very
red.
sorry to interrupt you. Can you show the working of the switch before you move on to this, please?
Yes. Sure, ma'am. Like this is the switch I have connected. Like, I don't you people understand the circuit, right? The positive has been connected to a common, and the terminal one has been connected to the positive end of the LED. So if I start simulating, the switch, the slider switch is being connected to the terminal 2. Okay. So if I slide the switch like this, or simply click the switch, the LED starts glowing.
Okay.
And if I again slide the switch, the LED turns off. Or you can say it's a simple switch circuit. When you turn on the switch, the LED is glowing. When I turn off the switch, the LED is off. I hope this makes...
got it. Yeah, thanks.
Thank you. So now we have a one terminal extra. So let us explore the terminal by connecting another LED to it. So let us take another LED. Similarly, this time I will change the color of the LED from red. Let's say it's green. Okay. So now, as I have told it to you people, like, we need a register to protect the LED. So first, we'll be putting a register here. Next, we'll go to the similar connection. The negative end or the cathode will be connected to the negative end of the battery. You can connect this negative end like this. Let us color code the negative end with black. And again, I have the positive end. The positive end will be connected to another terminal with a register. So this completes my circuit. Okay, so let's start simulating. So as I see, the slider switch is on the green side of the LED, or you can say on the terminal 2, the green LED is glowing. As I slide the switch to the red side, the red LED is glowing. So this is the purpose, or you can say the mechanism of a slide switch. Okay, so any questions, any doubt before we move on to another sample or another circuits? Okay. Yeah, so we can jump on to another circuits. So I believe everybody have got the principle of the slider switch, the LED, and the battery itself. Now, let us explore the same thing, or you can say the same switch and a LED with a push button. What is the principle of the push button? The push button,
till the time it will be on, the LED will continue to glow. We don't have to go, it is not that key. It has to be till the time it will be on, then at that point only. It's not on and off. We have to press it for the LED to grow.
Exactly, for the switch button, right? For the push button you're telling, ma'am, right?
Yes, sir.
Yeah.
Slide switch, so we can just move it, no? That's it.
Slide switch, you can just move
Ideally, you can move it and then leave it in case of a slide switch, whereas in the case of a push button, you just have to keep holding it continuously.
Exactly.
We can open and close the circuit.
We can open and close the circuit by just holding the button.
Yes.
Similarly, we have
I have a question here. I was trying to, in the previous example, I was trying to connect the cathode to the negative side of the battery. I tried to draw the line from the negative side of the battery to the cathode leg. I was not
Yes.
able to complete the line there. Anything that has to be done specifically with the mouse?
No, the thing is, you just have to click on the negative terminal. Your wire starts appearing. Okay, like this. And if you want to bend the wire, you again click the mouse like this. So
Okay, got it.
yeah, so it's make the circuits like you can make the circuit like this. Any other doubts, anyone? Okay. So let us explore the push button. To delete, you can simply click on the material or you click on the thing you want to delete and just simply click the delete from your keyboard. It will automatically delete the circuit, or you can delete the element you want to get rid of. So similarly, I'm making the connection for the push button. So this is my push button and this is my battery. Again, I connect one end. I connect the negative end to the cathode and the positive end has been connected with one end of the push button and the other end has been connected to the another leg of the LED, which is being connected to a register. If we start simulating the LED, okay, the LED is glowing for a bit. Just a second. Okay, it has to be connected in the opposite direction. The LED is off. So if you want to complete the circuit, I need to push the switch. I need to click on the switch, which makes the LED turns on. Okay. So remember this thing, whenever you are connecting a push button, it has to be connected on the opposite legs. If you're connecting it to 1B, and again, yours has to be connected in 2A. If you're connecting a circuit to 1A, it has to be connected in 2B only. So this opposite terminals you have to remember when you're connecting a push button, or else this thing will appear. That happens to me like this. If I connect the circuit, it will be on by default, or you can't like close the circuit, like break the circuit. It will be closed. The circuit will be on for forever. So make the push button working. You need to connect it to the either ends, either legs, like this.
Excuse me, sir.
Yes.
The same
Yes, ma'am.
question I'm asking you. Both the wire that we have to connect from the negative end, it is getting stuck over there. It's not coming.
Like see, ma'am. If you want to connect a wire, just click on the portion itself. Now you start moving to the direction you want to go. Now, if you want to bend your wire, like I want to bend it to the downer portion, so I just click on this free area again. The wire starts bending.
No, actually, problem is coming in the starting end. Wire.
When you are starting, you need to click on, like you will get a pop-up like this. Positive.
Yes.
You need to click on the pop-up. So the wire will appear again. When you click on, similarly, you drag your mouse, so the wire will appear accordingly. Are we able to do it now?
No, sir. Wire is only that negative and that red sign is coming, that small square. But I'm not able to pull that wire.
Like you have to stop your simulation before you make the circuit. Like if you
1 second.
if you start your simulation, it will not work. You need to stop your simulation and then you need to hook the circuit. This portion should not
Yes,
be
sir.
in
Got
green.
it. Got it. Thank you.
Thank you, ma'am.
In the previous example where you use the green light,
Yes, ma'am.
will you be able to repeat that example again, please?
Yeah, sure. Okay, this was basically my
You're connecting the third leg to
third
the
leg.
cathode, is it?
No, this
To the
is
anode, is it?
to the this is the anode itself. If
The
you see,
bent
this is
one
the
is the
anode.
anode. Okay, okay.
Yeah. Positive one is the anode and the negative one is the
One is the
cathode.
cathode, yeah.
So the cathode has been connected to the negative terminal
Okay.
over like this. And again, I connect the switch. So this completes my circuit and I can slide the switch accordingly. Either of the LED will glow.
Yeah, got it now.
So now we'll be exploring the thing called multimeter over here. So what's the purpose of a multimeter? So the purpose of the multimeter is to measure something. It can be either ampere or the current or the voltage or the resistance according to a circuit. For example, I have a register like this. The resistors already says it's having 1 kilo ohm resistance. So in my real life, I'll not be already getting. I can figure it out from the color code itself, but it's not always true that the real value of the resistance and the physical value of the resistance will be same. So that's why to check the real value, we just similarly use the multimeter. We connected the multimeter to one end of the register and the other end is being connected to another end of the register. Now I simply need to change the multimeter from voltage to resistance. The mode should be changed as resistance. And next, when I start the simulation, accordingly, it will give my resistance over here. Like it's 1 kilo ohm. Now, if I change my resistance, if I want to change the resistance to say 10 kilo ohm, so accordingly, it will change the resistance to 10 kilo ohm. So in real life, we can use multimeter to measure resistance, voltage, and current passing through a circuit. Similarly, if I take a battery, for example, let us take the small 3-volt battery, and I want to measure the voltage across the battery. So what should I do? The positive end or the red end should be connected to the positive end of the resistance of the battery. Like this is the positive end of the battery, and the negative end should be connected to the negative end should be connected to the negative end of the battery. So again, in the multimeter itself, we'll be changing the resistance to voltage as the battery works in a voltage. So it's the parameter of voltage. So when you start the simulation, automatically it will show me the voltage over the multimeter. So the voltage here, I'm getting it's 3 volt. So what happened if we alternate the circuit? So since we know there is a DC supply, what happened if we alternate the circuit? Let us explore that too. Let us connect the negative end of the multimeter to the positive end of the battery and positive end of the multimeter to the negative end of the battery. So similarly, it's nothing. I'm getting a negative 3 volt supply. So this is how we know the current is moving in which direction, from positive to negative or negative to positive. This is the principle how we can explore multimeter in our real life. Now we'll be studying the series and parallel connection. So as we know, series connections means something that are connected in a similar line. That's something that are connected in the similar line. I hope the annotation is visible.
Yes, sir.
Yeah. And parallel means that something is connected in this way. Like there's a one connection, there's a second connection, and there's a third connection. And this is the first connection, there's the second connection, and there's the third connection. So in case of resistance, if we connect a resistor, resistors has been defined by like this in our electrical circuit. If I connect a resistor in series, the resistor adds up. Like if I connect a resistor like this and this, for example, each resistance have 1 kilo ohm, 1 kilo ohm, and 1 kilo ohm. The equivalent resistance of the circuit will be 3 kilo ohm. Again, if we connect resistance in parallel, for example, I'm connecting resistance in parallel like this. So my equivalent resistance will be nothing. But 1 by R, the formula will be 1 by R by for equivalent resistance. If it is 2 kilo ohm, 2 kilo ohm, 2 kilo ohm each, it will be 1 by 2 plus 1 by 2 plus 1 by 2. So if we calculate, we can get it's nothing but 3 by 2 resistance, or the R is equals to 2 by 3. So this will be my equivalent resistance when resistance are connected in parallel. And when resistance are connected in series, they simply adds up. So now we know the theory of it. So let us implement in our circuit itself. So let us take a resistor. I can simply rotate the resistor like this. Resistor 1. And again, I take another resistor. It's 2. They're internally connected. And the resistor 3. So the equivalent resistance I'll be getting. So these are in series connection. So equivalent resistance I'll be getting will be 3 kilo ohm. So let us take a multimeter. And measure the equivalent resistance. As you see, the equivalent resistance already become 3 kilo ohm because they are connected in series, right? So if I connect these things in parallel, or you can say like this, they are connected in parallel. So let us take a multimeter and check what's the equivalent resistance now. For example, let us change the resistance to 2. Okay, so just a sec. Not allowing me to connect. Okay. Okay, the equivalent resistance come to be 667 ohms. So in parallels, it get divided. Similarly, I believe this series and parallel connection are clear to you people.
I think we will have to really do this to find out, especially in terms of, say, serial bulb connection and see how it works. Can you show me a demo?
Connection with bulbs, right?
Yeah, using a serial and a parallel connection.
Sure. So these are my 3 bulbs. Now I'll be connecting them in series. For example, let us put 3 registers to protect our bulb, or better say protect our LED. So for series connection, one end should be connected with the another terminal like this. Just a second. See, this is example of your series connection. So each of the negative terminal has been connected to each of the negative terminal, and each of the positive terminal has been connected to each of the positive terminal.
Yeah, got it. Just a request, can all the participants mute themselves, please?
I believe, just a second. All of you is better. It will be you people are on mute. Okay. So when we know the connection of switches and the LED, let us explore how AND gate or the AND logic is being operated. As we know, the AND logic means when two are yes, where the answer will be yes, or you can say A or B. There are two logics. If A is yes and B is no, the answer is no. When A is yes and B when A is yes, sorry, just a second. When A is no and B is yes, the answer is no. When A is yes and B is yes, the answer is yes. When A is no and B is no, the answer is no. This was in layman's term. So let us now understand how it is being written in terms of electronic devices, or you can say zeros and ones. We mean 0 means off and 1 means on. So A and B are my two devices. If A is on, if A is off and B is off, my AND logic will be off. And my if my A is on and B is off, the AND logic will be off itself. And the A is off and B is 1, the AND logic is also off. If A is on and B is on, the AND logic is on. So this truth table is clear, I guess. Any doubt in this truth table?
No.
No, sir.
Yes. So let us experiment this truth table with the help of a circuit. Okay. So we have, now let us take two switches. Let us take two slide switches. Let us name one A and one B. you can use this thing, or you can use this annotation to give annotation to it. So this is my A. And this is my B. So here I'll be using a AND logic gate, or you can say if we type AND over here, you will find a logic gate called AND. Okay, there's a quad AND logic gate over here. So this is my AND logic gate. So it has input 1, input 1A, input 1B, and output 1. Similarly, it has input 2A, input 2B, and output 2. And one is ground over here, and one is power over here. So it is input 4, and again it is input 4B, 4A, and output 4, 3B, 3A, and output 4. So there are 4 AND gates. So 4 AND logic gates over here to implement the circuit. For example, let us take the 9-volt battery and let us make the connection. So we'll be using this upper portion of the breadboard to make our connection. I'll hook the positive terminal to the upper portion. That means throughout the line, I'll be getting positive supply. And let us hook the negative end to another upper portion, or the upper negative end. From the throughout of this end, I'll get the negative supply. So in the AND gate also, the ground need to be connected to the negative end, or let us better color code it. The positive has been color coded as red. So the ground has been connected to the negative end, and the power has been connected to the positive end, like this. So this connects my AND logic gate. So I'll be using terminal 1 for this demonstration. So terminal 1A, I'll be connecting my A circuit over here, like this, and connecting my A switch. Okay. In 1B, I'll be connecting my B switch. So this make the connection, and the another end of the switch should be connected to the terminal, or the positive end of the terminal, and another should be similar for the B switch also. Okay. Now let us take a LED for our output. The cathode has been connected to the negative side, and for the anode we connect a resistor, and the resistors has been connected to the output of our AND gate. This is the output. One output has been connected to the output of our AND gate. So this makes my connection complete. So my answer will be, if I turn on any of the switch, either any of the switch, the LED will turn off. If I turn both of the switch together, then only my LED will go, according to the truth table. So let us explore. Okay, for this we will be needing a 5-volt supply. Okay, because every chip works in a 5-volt supply. That's why you see the 9-volt supply turn or the burst the chip. For that, we'll be requiring a power supply. Search power supply from here, and you will get this huge box. It's nothing, or you can say the variable power supply. Similarly, positive has been connected to the positive with red, and negative has been connected to the negative, like this. So how to change the power? Here you can change the voltage and the current accordingly. Okay. So I am giving a 5-volt supply to it. So let us start the 5-volt supply simulation. So now my LED, now my chip is not bursting. So it's 748C08 chip. So it's an AND chip. Okay. So now if I turn both of my, so let us, when A is 0 or A is off and B is off, the LED is off. When A is on and B is off, the LED is off itself. When A is off and B is on, the LED is also off. When both of them are on, the LED turns on. So this satisfies my AND logic, or the AND gate, you can see. I hope this is clear. Any doubts till now?
No.
Can you repeat this part, please? Like when the on and off, just now what you showed.
Yes. The thing is, see my truth table. First of all, the truth table say A is 0 or B is 0. That means I need to turn off the switch. So my both the switches turn off. Okay. A is off and B is off. So now the second part is A is on and B is off. Then also my output is off. Again, in the third part, A is off and B is on. Then also my output is off. In the last part, A is on and B is on, which makes my output as 1. Or you can say the output is on, the LED is glowing. Clear, ma'am?
Yes, thank you.
Okay, thank you, ma'am. So next part will be verifying another logic gate, or you can say the or you can say the OR logic gate. This is our AND, this was our AND logic gate. So that let us explore the OR logic gate. The OR logic gate says if this is 0 and this is 0, the output will be 0. If this is 1 and this is 0, the output will be 1. And if this is 0 and this is 1, the output will be 1 also. And this is 1 and this is 1, the output will be 1 also. The AND logic gate, the OR logic gate simply says that if either of the input is in the highest state or either of the input is on, the output will be on by automatic. Okay. So see, if both the inputs are off, then only I get a negative output, or else I'll get a positive output, or you can say the highest state of the output. So how to check it? I just have to replace the similar circuit with another chip, or you can say the OR chip. Let us take the OR chip from our circuit. OR gate. We'll get this quad OR gate. Okay. Let us delete this and let us hook this gate together. Okay. Now similarly, this one is ground. Ground has been connected with the ground, and this one is power. So I'll connect the power with a positive end. And this one is 1A, and this is 1B, and this is output 1. So this is my OR gate with the OR chip, and the connection remains the same. So let us verify the OR gate. Okay. The first is when A is off and B is off. A is off and B is off, the output is 0. When A is on and B is off, the output is on. Again, when A is off and the B is on, the output is also on. Again, when both the things are on, the output is also on. So this is nothing. You can say the verification of AND and the OR gate itself. I hope this till now, any questions from anybody? Okay. If no, then let us move to another portion of the circuit. Okay. So now I'll be introducing two things to you people. One is our DC motor. Okay. DC motor is nothing. It when we give a power supply to it, the motor starts revolving around it. For example, if I get a 9-volt supply, I connect it to the positive end, and the negative end has been connected to the negative end. If I start my simulation, the motor rotates. You can see the motor is rotating with a certain amount of RPM, or you can say 17568 RPM. This is how the motor is rotating. Again, if I stop it, or you can disconnect the circuit, the motor is not rotating with 0 RPM. So this is the work of a DC motor. Just okay. So now we'll be introducing potentiometer to you people. You have seen register, like this is our register. You already have worked with registers with LED and all. So potentiometer is what is nothing with a variable resistance. When you move the terminal of the potentiometer, the amount of resistance, it increases or decreases. Okay, you can check it by connecting a multimeter to it. There is a multimeter. Let us connect it with the terminals of the potentiometer. See, when it is connected in this low orbit, the resistance is 0. As I keep on turning the potentiometer, the resistance keep on increasing. The resistance keep on increasing till 250, because the upper limit has been set to as 250. I can increase this upper limit to any 500 kilo ohm. So my resistance will increase like this. This is 0. As long as I'm increasing the resistance, the amount of, as I'm moving the knob of the potentiometer, the resistance is also increases. So potentiometer is nothing, or you can say the example of your variable resistance. We can easily change the resistance according to our need in the case of potentiometer. So where do we use? We use when we need a variable resistance, or you can say good example is your fans, is your AC fans. We have a regulator. Regulator is nothing, or you can say the example of your potentiometer. When we turn on the regulator, the resistance increases, or the fans move slowly. When we again turn off the regulator, the fans again start turning in a higher speed. So this is the example of your potentiometer. So let us take a breadboard like this. Let us take a breadboard and let us connect the potentiometer. Again, let us connect the circuit. So let us use the upper terminal. Negative has been connected to negative. Positive has been connected to positive. The negative terminal has been connected to a negative terminal. One of the positive terminal has been connected to the wiper, and the another has been connected with a potentiometer to the positive end of the battery, like this. Okay. So if I start, this time my resistance is 0. Okay. So let us check with the, also take a multimeter so that we can check the resistance also. The resistance is 0 over here. So the RPM is also high. See 19520. It's rotating at higher speed. As I keep on increasing the resistance, the RPM start decreasing. Okay, just a second. Yeah. So here it is. Now the resistance is 18 kilo ohm. The RPM is so low. When I again reduce the resistance to 6 kilo ohm, the RPM is high now. So you can check out with this. When the resistance is very small, the RPM is very fast. Accordingly, it changes the speed. The motor changes the speed according to the potentiometer. So this is a very good example of your fans that we use, the regulators of the fans that we use.
Where is the negative of the multimeter connected?
Okay, just I make a circuit in a better way. This is the multimeter. The negative has been connected to another end like this. The
But
positive
is it not noted in red? Because you see that the other connection is in red, and that is getting into the positive side of it.
Because this is a potentiometer. Like we are measuring this particular resistance of this particular circuit, not the whole circuit. We are measuring the resistance of this particular potentiometer, not the whole circuit. That's why you are connecting it to a with a black to a negative end. If you want to make the if you want to take the resistance of the whole particular circuit, I have to connect it to this terminals, like this proper terminals with positive and with negative. This will give me out a different voltage and a like this giving me 9 volt. And if I change this to ammeter, it will give me 6 ampere current. And again, it is giving me some amount of resistance. It will not show because no load has been connected to it. To check the resistance, I need to connect a load or any potentiometer or any devices. That's why the connection is being made like this. This goes to the wiper. One end goes to the wiper and one other end goes to the another terminal. This is actually giving me the resistance. As I increase the resistance, the RPM keep on decreasing. Similarly, I can change this to, let's change this to 200 so that I can get a better result. So the RPM is 7. When the resistance is low, the RPM is high. I have this is done, I guess. So any doubts till now about the circuitry, about anything we have done today?
We will get to know only when we dirty our hands.
Sorry?
We will be able to, understand whether we have understood or not, only by dirtying our hands.
Yeah,
We'll
sure,
have to
sure.
try it out.
Yeah, sure. That is what this is for. This TinkerCAD is an open source platform. You can log in and do it anything. Like do anything you want. Explore it. TinkerCAD is not only what I teach you people. Like what this is not anyone's limitation. You can take any of the circuit, any of the electrical circuits and play with it. Like you can do anything with it. Even in the higher classes, we'll be doing Arduino with it. We have Arduino. We'll be connecting with the different other sensors. So ThinkerCAD is a very good platform when you are doing some electrical devices or studying your electrical or basic electronic ideas. Will get it cleared. So another before like winding this class off, I'll give it to you another example of series and parallel. You can say, let us take this. This is a battery. We have seen series parallel in resistance, but we'll now see series parallel in batteries. Again, this is a battery, or better let us take a 9-volt battery. Okay, it's not. Yeah, there's a 9-volt battery. So if I simply check the resistance over here with a negative and a positive one, sorry, not resistance, the voltage, I will get a 9 volt. So now let us connect two batteries in series. Everybody, yes, sorry. So everybody have seen battery connection in series like this. The negative ends goes to the positive, and here we get. So anybody can guess what will be the desired output. It's 18. So similarly, the 9 volt and the 9 volt gets added up. 9 plus 9 gives me 18.
While putting these batteries, we are having any option in drop down something parallel, this series or parallel. Can you show it once again? We have an option.
Option it will get if you connect this 5-volt batteries. Okay,
Okay.
these
No,
are
sir,
yeah,
actually, how
yes,
it
yes.
understood that is because हमने उसको place तो line में ही किया था. We placed in them in a line. Then how it is parallel या वो?
Ma'am, like we have to go for the connection. ये connection है. पैरेलल में
हाँ.
क्या सीरीज में क्या हुआ, नेगेटिव का पॉजिटिव पे गया, ठीक है, और फिर ये कनेक्शन होता रह गया. लाइक इफ आई टेक इट 3 ऑफ इट, द नेगेटिव गोज टू द पॉजिटिव and the connection continues like this.
Okay.
In parallel, what we does, like if this is our parallel connection, if these two have been connected in parallel, the positive will be connected to a positive itself like this,
Okay.
and the negative will be connected to the negative itself like this. So this is our parallel connection, and this is our series connection.
Got it. Thank you.
Yeah. So I'll get a positive end, a negative end from this, and a positive end from this. And for the series connection, I'll get a positive end from this and a negative end from this. So if you've seen your remotes, like your remotes, it has a series connection because they're internally shorted over here. These are connected in series. Your remotes have been connected in series. That's why we get a better power source when we use 2 or 3 batteries in the remote. इसलिए हम लोग जब बैटरी लगाते हैं रिमोट में, एक सीधा लगाते हैं और एक उल्टा लगाते हैं. That is the main principle. When positive goes to the negative and negative goes to the positive, it
That
jumps off the
series
connection.
connection, right?
Yeah, series connection.
Series. Thank you so much.
So I'll open the decks for any questions you people have, like any sort of questions, anything you have gone through, anything you want to discuss, anything for this class. Open to questions to everybody. You can either speak or you can either write in the chat box itself.
After the previous classes, we looked into the design aspect in TinkerCAD. How do we use these various shapes and then create some kind of design outputs out there? But right now we are looking into the circuits, right?
Circuitry,
Are we
yes.
going to put both of them together?
Like you, ma'am, it's always like you can put it together. For that, as in the last class itself, you know how to make the 3D models. Now you can print a 3D model. Again, in the 3D model itself, you can put the circuit together. But in the simulation platform, if you are talking about in the TinkerCAD itself, there is no such method you can put the 3D model and the circuit together. But in the real world, you can. You can definitely with your hardware, or you can definitely with the 3D printers.
So ideally speaking, that class and this one are mutually exclusive. We don't have
Yeah.
any connection.
No, there are no connection. They are mutually exclusive. But when you are making a product, for example, everybody has signed up for STEM and robotics. In the final product, if you're making a robot, we need to design the robot in our 3D model itself. We need to design the robot as a 3D model, going through the eyes, nose, face, everything. Again, after designing a 3D model, the robot has some mechanism, the electrical circuit, its brain, that has been connected in an exclusive part. And when we put both of them together, it actually what we get as a result, or what we get as a robot, you can see.
Okay, in the class that we had all joined, I have created a simulation for the AND gate, but for some reason it is not working. Will you be able to share the screen and tell me what mistake I have done?
Yeah, sure, ma'am. You can, like, if you want, you can go over for the screen sharing.
Yeah, you can share it from your end. The student name is Lakshmi.
Okay, just a second. Actually, I don't have that access at this point of time. Okay, so it'll better if you go and share your screen.
Can
Really
you?
great. I am allowing you. Just a sec. Yes, ma'am. You can now.
Are you able to see?
Yes.
Yes.
You are able to see? Okay, so I have used the 7408 circuit, and this is what I have done. I just want you to tell me the mistake I have done. I have used a 1.5 volt out here.
Okay. So one mistake I can see that your terminal two of the switch 2 is been shorted with the another terminal of your gate. Like if you hover it to the terminal 2 of the switch 2, this is
Here?
not no, the other side.
Here?
Yes, both are connected. See, ma'am, a small line is showing, which means they are connected. It's the principle of the breadboard. They are connected.
Right, these are connected, right? So
Yeah, these are
ideally,
connected.
I wanted the input. This is the first input. This is the second input.
Now what you have to do, you have to give a power supply to the chip. If you hover to the upper end of the chip,
from here, I have to go into the positive side. Am I right?
end. Yeah.
Okay.
So, actually, this will make your connection faulty because your switch has been connected to a power supply also, and your
Yes.
and the chip is also been connected to the power supply.
Yes.
Right. So now you have to separate your connection from the switch. Now you have to go one step back of the switch.
So shall I remove this?
Yeah, you can remove this.
Okay.
And remove the switch one step to the left.
Here.
Yeah.
Okay.
Now place the connection. Now
this one I will move it further.
This one
here.
is fine. This one is no. That one was fine.
Okay, so from here I will have to connect. Am I right?
From the common terminal you have been connected.
I have to connect it from the common terminal, is it?
Common terminal, yes.
Oh, okay. I think I made a mistake there. Okay, so from here I will have to connect. That means in this
Here
connection also I will have to connect it from
Exactly.
the common terminal to this. Am I right?
Exactly.
Okay.
Now,
anything else?
Yeah. Now you have to give a power. You have to complete the connection of the switch also. One end of the switch is connected, another end is not connected. Right, ma'am?
No, you mean to say that one end of the first switch is connected and this is not connected is what you say.
Terminal 1 of the switch of both the switch are not connected. So you need to connect the terminal 1 with the positive end of the switch or the positive end of the battery.
So this is how you will connect it?
Yes, sure.
Okay.
Same for the switch
second one. So second one also I'll have to connect it. Am I right?
Yes.
Have I made a mistake here?
No, it's okay.
Okay. Then
Then just you need to start the simulation now.
See,
Okay. Just a second. You have to like ground is being connected, right?
yeah, see here.
And the ground of the chip has been connected.
Yeah, here the ground of the chip has
Okay.
been
Now
connected here.
give the power supply to the chip. You haven't given the power supply to the chip.
So from here I'll connect.
Yes, to the positive end.
Okay, it's
Yes.
correct.
Yes. Yes.
Still, it is not glowing. Ah, now it is glowing. Okay,
Okay.
so both the things are on. So it is working. So
So
this
it's
is
working.
off, therefore it is not working. So
Sure.
this is off and this is on, it is also not working. Both the things are off, it is not working. Right? Okay.
Yes, yes.
Now it makes sense. Yes.
Okay.
Thank you.
Thank you, ma'am. Thank you. Any other question? Anyone else? Yes. Anyone else you can go through? Okay. So I hope there is no more question from anyone's end.
So just we need to be a little hands-on and we'll try the
Yeah,
things
sure.
and then
Sure, sure,
let's
sure.
just
You
play out.
can
Let's just play out.
you can practice it, and when we again next meet in the next class, if any issues you'll be facing, we can always we'll be always there to resolve it.
Yes, sir.
Okay. So
Thank you.
with this I end this class, or I end this session. Thank you everybody for joining. Thank you for giving us time. Thank you all.
Thank you, sir.
Have a nice
Thank
day.
you. Thank you.
Thank you, sir.
Thank you, ma'am.
Thank you, sir.